Today, we're going to dive into one of the most fascinating frontiers in technology. How do we get these brilliant individual AIs to stop working alone and actually start collaborating like a real team? I mean, think about it. A single modern AI, it's already a powerhouse. It can be a brilliant coder, a visionary artist, or a data scientist that spots trends in milliseconds. It's an incredibly capable employee, right? But here's the catch. For all its power, that AI is basically working in a vacuum. It can't just lean over to a coworker, another AI, and say, hey, can you help me with this? Or delegate a task, or brainstorm a new idea. It's missing that one fundamental human skill: teamwork. So that brings us to the big question for this explainer. If one AI is like a brilliant employee, how in the world do we build an entire organization out of them? How do we get them to talk, coordinate, and achieve goals that are way beyond what any single agent could do alone? Well, the very first step, just like in any human organization, is you've got to create a shared language. For AI agents to work together, they need a clear, totally unambiguous way to communicate. And we're not just talking about sending data back and forth. It's about conveying actual meaning and intent. The foundation of this language is syntax. You can think of it as the basic grammar. It just makes sure a message is structured correctly so it can even be read in the first place. And what's really cool is how this has evolved. Early protocols use this complex Lisp-like code, but modern systems, they use something simple and familiar like JSON, which is already the language of the web. Okay, so once you have the grammar, you need the words. That's semantics. This is the shared dictionary. It's a shared rule book. They call it an ontology that makes sure when one agent says the word order, every other agent understands that term in exactly the same way. No ambiguity, no misunderstandings. And this brings us to pragmatics, which, honestly, might be the most important part of all. This is the why, the intent behind the message. Is the agent making a request? Is it just stating a fact? Is it making a proposal? Early protocols were smart about this. They made it explicit with a performative verb right at the start of the message, a label that basically says, hey, here's the purpose of this communication. So, with the language all defined, what tools do these AI agents actually use to talk to each other? Well, the whole field has seen this massive shift, moving away from old, rigid systems toward a new, much more flexible stack of tools that are really designed for the modern, decentralized web. Just look at this contrast. The old way, using protocols like FIPA, ACL, was kind of like giving every agent a single, massive, and super complex rulebook for, well, everything. Yeah, it was powerful, but it was incredibly rigid. The new way? It's a whole different philosophy. It's a modern toolkit, a stack of specialized, simple tools that each do one thing really, really well. And here's that modern toolkit in action, using our organization analogy. You've got MCP, which is like the internal wiki an agent uses to understand its own tools. Then there's ACP, which is basically the company-wide Slack channel for agents to delegate tasks and send updates. And finally, ANP is like the HR directory for finding other agents and verifying who they are. This whole approach is called protocol stacking. And if that sounds complicated, don't worry. It's not a new idea. In fact, it's exactly how the internet itself is built. You have these different layers like TCP, IP, and HTTP, and each one handles a specific job, and they all work together to create a complete system. It's a proven, super robust way to build complex systems. So let's look at the first layer, MCP, the Model Context Protocol. The best way to think of it is as the USB-C for AI. Now, this is not for agent-to-agent communication. Instead, its whole job is to create a universal standard so any agent can connect to any external tool, an API, a database, whatever, without needing a bunch of custom code. Then you have ACP, the Agent Communication Protocol. This is the actual communication highway between the agents themselves. It's built on REST, which is the same technology that powers most of the web, and that makes it incredibly simple, lightweight, and really easy for developers to use for delegating tasks and getting status updates. And finally, there's the Agent Network Protocol, or ANP. This is the crucial social layer. I mean, how does an agent find a colleague with a specific skill? And how does it know it can even trust that colleague? ANP provides the system for agent discovery, for decentralized identity, and for secure connections. It's what turns a collection of individual AIs into a trusted community. Okay, so our agents have a language, and they have the tools to talk. But how do they actually run a project together? They need more than just messaging. They need standardized rules of engagement for actually getting work done. And one of the most powerful and widely used set of rules for this is the contract net protocol. It's essentially a standardized business process for our AI organization. It creates this little mini marketplace, allowing a manager agent to announce a job and then subcontract it to the best available contractor. The whole process is actually beautifully simple and structured. First, a manager agent sends out a call for proposals that describes the task. Second, any interested contractor agents submit their bids, proposing their terms, like price or completion time. Third, the manager evaluates all the bids and awards the contract to the winner. And finally, the winning agent gets the work done and reports back with the result. All right, now let's zoom out. When you combine this shared language, this modern toolkit, and these standardized project workflows, you can build more than just a team. You can actually start to build an entire agent society that can solve incredibly complex real-world problems. And this isn't just science fiction. The stuff is happening right now. In smart grids, you have agents trading energy in real time to prevent blackouts. Autonomous vehicles are negotiating maneuvers with each other to make traffic safer. And in supply chains, agents are coordinating logistics to respond to market changes instantly. So the big takeaway from all of this is really a shift in perspective. That classic sci-fi trope of a single, all-powerful superintelligence, it might be missing the point entirely. The real future of AI isn't about building one giant brain. No, it's about building a robust social and economic infrastructure, the language, the tools, the rules, for a global society of specialized collaborating agents. And that leaves us with one final and pretty crucial question. As we build this new economy of autonomous agents all working on our behalf, who gets to write the rules? Who defines what's fair, what's secure, and what's ultimately beneficial for humanity? That is the great challenge and the great opportunity that lies ahead.